I'm Geoff Dabelko at the Woodrow Wilson Center here in Washington, D.C., Director of the Environmental Change and Security Program, and I'm having a chat with Cleo Paskal from Chatham House, who is somebody working on climate change, energy, and security issues, doing some consulting for our U.S. Department of Energy on these issues. So Cleo, tell me, we think a lot about energy consumption and what that means for climate change, but what about the opposite direction?
Climate change is going to have a very large effect on the ability to extract, distribute, refine energy in every sector. So for example, hydrogeneration, when you build a dam, you do a site inspection and you see what the precipitation levels are, where the rivers are, that sort of thing. And you assume that those are constants. Mm-hmm. You assume that there'll be the same amount of rain every year, that the rivers won't change, that sort of thing. Mm-hmm. Those constants have now all become variables. So your hydrogeneration is going to be severely affected. In India last year, they had an 8% decline in the ability to generate hydroelectricity because of changing precipitation patterns. This year, so far already, it looks like it's going to be 12% because the monsoon is failing. And you have the added problem that without the rain, usually the temperatures are higher, so the demand is increasing at the same time as the ability to generate is dropping. And we're seeing that here as well. Places like the Hoover Dam, the reservoir levels are going down. So the ability to generate is impaired. But at the same time, when the rain does come, often it comes as very strong storms. And so you're getting increasing siltation, erosion, which in itself could undermine the stability of the dam infrastructure. So not only is your ability to generate impaired, but your actual infrastructure might be compromised. That's hydro. When you're looking at other sectors like nuclear, for example, nuclear also needs a large amount of water. So it's either built on the coast, which means that it will be subject to rising sea levels, increasing storm surges, coastal erosion, which again could affect not only its ability to generate, but also the structural integrity of the installation. Or else the nuclear installations are built on rivers, which is an even bigger problem because the river levels are declining, the temperatures are increasing. And we've seen those problems already in France in the summer of 2003. Over a dozen French nuclear plants, because it was so hot, had to power down or shut off. And it created a situation where France had to buy energy from neighboring countries. It cost France Electric something like 300 million euros to make up the deficit for that summer. And people go, okay, it's a one-off, it was an extreme event, but the predictions are that the temperatures that we saw in 2003 will be a 1 and 2 year event by 2040. And we've already seen in France, they had to power down again in 2006 and again this summer. So those are problems in nuclear. When you're looking at offshore, places like the US Gulf of Mexico, you're seeing increasing storm activity, increasingly strong hurricanes that are destroying platforms, or even the threat of the storm activity is causing an evacuation of the platforms. So Katrina and Rita, they destroyed about, well, over 400 platforms, as well as refining capacity onshore. That creates a global spike in energy prices, apart from having to rebuild the infrastructure. And you're seeing many areas that have offshore oil and gas or coastal oil and gas, like the Niger Delta, is very susceptible to sea level rise, potentially increasing storm surges, that sort of thing. The Arctic, it may have an opportunity for opening up new areas of offshore, but the onshore facilities are built on permafrost, and the permafrost is thawing. So that's becoming increasingly unstable. Your pipeline is only as good as its weakest point. If it's built on an area of thawing permafrost and the pipeline breaks, you've lost your delivery. So in many different sectors, energy sectors that we rely on, you're going to very likely see increasing instability in the ability to extract, refine, distribute, generate.
Well, that really does suggest then we have to look in both directions, energy to climate, climate to energy, and then what that means in a larger security context. Well, we'll look to your publications and your work for keeping us on these obviously critical questions, and one that I think we can say so far had been not given enough attention. So thank you very much, Cleo.
Thanks. Always good to see you.